Hey everyone, welcome to your Play Posit for today. We're going to be covering 4.05 to 4.06. So go ahead and grab your notes, have your graded questions assignment open, and let's get started. Grab my pencil here. So today we're going to confirm the accuracy of various shapes. So we're going to be using things like the distance formula and our formula sheet with perimeter and area. Be able to find different values of shapes. I'm also going to show you something really cool on the Desmos calculator. All right, so what is the area of a rectangle with these vertices? This is from last class, so I just kind of wanted to wrap back around on this. When you're given these coordinate points, we're going to go ahead and plot them. I'm going to label them A, B, C, and D. So we start at the origin in the center. We'll go in the x direction first. -4, 0 is A. -3, 1 is B, and 0, -2 is C, and -1, -3 is D. All right, so now we have a rectangle here. It tells us it's a rectangle, so we can go ahead and connect our points as best we can. There we go. So it wants us to find the area. You guys probably know area of a rectangle is length times width. If you don't, you can check your formula sheet. And you're allowed to have that formula sheet for the whole class and on the SOL. So we're going to need to know the length of this box and the width. So sometimes people think that they can just count the number of units, but you're only allowed to do that if it's oriented directly on the grid line marked. See, something like this, we could say, oh, this is 2 by 1. We can't do that when it's here on a slant because it's not exactly one box. So we're going to need to use the distance formula to find the length of that segment. And the distance formula is we take the x coordinates and subtract them and square it, and do the same thing with the y coordinates and square it. So I like to label them so I don't get anything out of place. So we could go from A to B first. So I'll label this x1, y1, and x2, y2. So let's plug in our values. X2 is -3, x1 is -4. y2 is 1, and y1 is 0. Just be careful with the minuses and the negatives because there's a minus in the formula, right? But then also our x coordinate here is a negative. So a negative times a negative, we add these together, we get -7 squared and 1 squared. So this is 49 plus 1 is square root of 50. So that's the length between A and B. So now is when I'm going to show you something really cool. On our graphing calculator. So let me just grab these coordinate points. And all right, we're going to go to the Desmos graphing calculator for Virginia. Make sure you're using the Virginia version. And when you click into this bar, you're going to open the calculator keypad at the bottom and go to Functions. And go to MISC for miscellaneous. And then down here you have distance. So there is a function on the calculator that will let you find the distance between 2 points. We're just going to plug these points in with a comma in between them. And there it is. It is, let's see if I did that. Make sure I did that right. I'm going to go back to my PowerPoint really fast. So I think I did something wrong. Have you guys seen? Because square root of 50 is 7. It's not the same as 1. So let's see what we did wrong here. And it does appear to be more closer to 1 than it would be to square root of 50. So let's do some error analysis. This is why I love the calculator, because it'll help us confirm our work. right? So I must have done something wrong over here with my calculations, and maybe you already figured it out, and maybe you're screaming at the screen going, Miss Winslow. So let's do this error analysis together. So make sure I plugged it in right. X2 is -3, X1 is -4. Oh, I already see it. Look, here, keep, flip, change. So -3 plus 4 is 1, not -7. There we go. That makes much more sense. 1 plus 1 is 2, square root of 2. Let's see if square root of 2 is the same as 1.41. Yay! Sure enough, it is. So now these two match. Excuse me, the square root of 2 we got by hand, and the distance formula we got using the calculator. Perfect. Now let's do this again, and we'll find the distance between the other two. The other 2 points, C and D, we had 0, -2, and -1, -3. Make sure I copied that right. 0, -2, -1, -3, and we get 1.4142. Is that the same thing? It can't be the same thing. Whoops. It is. Okay, I grabbed the wrong points then. Yeah, I just found the other end. So we confirmed this is also square root of 2. So now let's find from B to C. So B is -3, 1. Go back to our calculator and it's here. There we go, 4.47. So now we need to find the area. So this is 4.47. So the area of a rectangle is just length times width, right? So we're going to do 4.47 times square root of 2. So we'll go back to our calculator. So we'll multiply this. You can do, I think it's ANS for answer. I think that should work. That's how it works in my, oh, it doesn't work that way in Desmos. Interesting. I'll just copy and paste. There we go, 6.3, let's say 6.3. So our area is 6.3 units squared. Since we don't know the units, we're just going to say units. So here's the thing with all these problems. Here's the next one. What is the perimeter of the rectangle shown? So perimeter, you can go to your formula sheet and you'll see that it's 2 times the length plus 2 times the width, right? You just add up all the edges because there's 2 widths and there's 2 lengths. That's how they got this 2 here. And you guys see you're going to do the exact same thing. You're going to find the distance or the length of each of these segments and then add them together. So you can use the formula sheet. Sorry, you can use Desmos for that, or you can use the distance formula. Same thing with this one. What is the perimeter of the triangle shown? So again, you're going to match it up to our formula sheet. The perimeter of a triangle, you're just going to add up all the edges. So there's really no formula for that. You're just going to add them up. This plus this plus this. Right, so use that distance formula, use the distance feature on the calculator, find the lengths, and add them up. Same thing with this one. So they give you a parallelogram. So this time you're going to want to go and find the parallelogram on your formula sheet. Here it is. I'm going to take a snip of that for us and put it on our presentation. And once you plot these points and connect the dots, you'll see a shape that looks just like that. And again, you do the same thing. You're going to use the distance formula, or you're going to use the Desmos calculator to find the length of the 2 bases and the height, and then you're just going to plug it in. Whoops, there we go. I feel like a broken record, right? This is the exact same. You're going to find the missing links that you need, and you're going to go to your formula sheet and find the rhombus. Here's the rhombus. Right? Put it in here for us. This rhombus on your diagram is turned a little bit, right? And that's okay. You can still find the lengths of each of the sides, plug them into this formula. Again, you can use the distance formula. I'll write it up here. I would write it down in your notes for sure. You subtract the x's, square them, subtract the y's and square them, and then take the square root. Or you can use that MISC distance feature on the calculator. Either is totally fine. All right, so we're going to review parallel and perpendicular lines, something that you most likely recall from Algebra 1. So let's recall coordinate points. So I know that we've been plotting these points in the last few examples, finding the different shapes. But remember, you're always going to start at the origin here. And you're going to go in the x direction first. So A, let's find A. A would be over 2 and down 1. So coordinate point A is 2, -1. So just kind of reviewing, making sure that you guys remember how to find those coordinate points. Coordinate B would be 6 over and 2 up. And lastly, C would be -5 and 3. So just remember that you go in the x direction first and then the y direction. So now we're going to go the other way. Let's plot point A. We'll go -1 first and then up 2 because it's a +2. So the coordinate point goes in alphabetical order. X comes first and then y. Point B is -3, -4. C is 3, 5. I'm sure you guys all got this down. If you need any help with this, let me know. D is 1, 0. It reminds me of Battleship. Did you guys ever play Battleship, that game? All right, let's recall slope. So slope is the steepness of a line. You can see this picture here. Sometimes you might see signs like this on the highway that there's a steep turn coming up ahead, especially for large trucks. And so it's how steep a line is. And we usually represent, not usually, we always represent slope with the letter M. And we have a formula to find it. But first, let me show you in Greek letters. It's delta y over delta x. Delta meaning change. So it's the change in y over the change in x. So when you think of the word change, I think of subtraction, like the difference between two things. So here is our formula to find slope, x1 minus x2. I'm sorry, let me erase this real quick. It's the change in y, y2 minus y1 over x2 minus x1. So you find the slope between 2 points. Y is on the top and x is on the bottom. And we'll go over this more in the next few slides. So the first one we're going to talk about is a positive slope. So you can see this gentleman here, he is going up from left to right, and that graph is increasing from left to right. So we say a line that has a positive slope increases from left to right, like you would read a book. From left to right. The line is going up, right? Here's our negative slope. The line is going down from left to right. So the line is decreasing from left to right. And I think a lot of you, probably all of you, could very easily tell me, oh, that's a negative line, right? We know negatives go down. There's two more. They're kind of special. This one is a vertical line straight up and down, and that is an undefined slope. So vertical lines always have undefined slopes. And look, he's saying, help. The way I remember this is if you were to draw, this is silly, but if you were to draw a vertical line, and I can make a big U for undefined. So the big U makes up 2 vertical lines. It's just kind of one silly way to remember undefined. The vertical lines have undefined slopes. Because the line is not, going up or down. It's just straight vertical. And the last line is a horizontal line. So I always think of like the conveyor belts at the airports. If you guys have ever been to an airport, they have those people movers. You just stand on the line and it'll take you and your luggage from one place to another. So that line is neither increasing or decreasing. It is just a straight slope, straight horizontal. The horizontal lines have a slope of 0. So sometimes people get undefined and 0 slopes mixed up. So that's why I feel like that U trick helps people sometimes. So we briefly talked about this before. When you have 2 coordinate points, x1, y1, and x2, y2, to find the slope between them, we have our formula, the change in y over the change in x. And we're going to do some examples on the next slides, but you're definitely going to need this formula, so definitely write that down. So let's practice. I'm a big labeler. I'm going to label all these x1, y1, and all of these x2, y2. And put our formula here at the top, change in y over change in x. And then you just plug it in. So point A, we're going to do 4 minus 1 over 0 minus negative 4. Four minus 1 is 3, and this is a positive 4, right? So we're just plugging the values that I labeled into our formula. And you guys can always pause this recording and try these on your own, right? So we're going to have 4 minus 1 over 4 minus 5. 3 over negative 1. I'm going to put C up here. Negative 1 minus 3 over 0 minus 2. You guys, I wish you were here. You could tell me if I'm making any mistakes. But I think I'm good. D is negative 3 minus negative 3 over 7 minus negative 2. So you do have to be careful, just like that distance formula. You have a subtraction, but then some of your coordinates also have a negative. So just be super careful. So this becomes 0 over 9, which is 0. So we know right away that that would be a horizontal line, right, with the slope of 0. All right, so let's find the slope. So here we have a line, and it's a vertical line. They give you 2 coordinate points, so we can use the coordinate points if we want to. You guys can also just look at it. You're probably like, duh, Miss Winslow, it's a vertical line. We know vertical lines have undefined slopes. So let's see why. Let's plug these numbers into the formula. This is a 2. So we're going to have negative 5 minus 5 and negative 4 minus negative 4. Right? Yeah. Let me grab a different color. So keep, flip, change. So we have negative 10 over 0. So this is where you probably learned at some point that you can't divide by 0. It's not allowed. And it's not allowed because it doesn't make sense, right? You can't have 0 groups of negative 10. And if you were to plug this into your calculator, it would tell you undefined, or it would say error. So this is undefined. And we know vertical lines are undefined. So perfect, it matches up with what we thought. Same with this one. We have our horizontal line here, so that we know horizontal lines have a slope of 0, or 0, m. But we can also find it. Let's take any of the 2 points on this line, negative 2, 2, negative 2, negative 2, and how about 1, negative 2? We'll just try these 2 points. So we'll have -2 minus -2 and 1 minus -2. So many -2's. Keep, flip, change. 0 over 1. Nope, 3. You can have 3 groups of 0, or 0 groups of 3. 0 groups of 3 is 0, right? 0 divided by 3 is 0. So it does, in fact, match up with what we thought of a horizontal line having a slope of 0. All right, so you can find the slope from 2 coordinate points, but you can also find it from a graph. And you guys probably recall this from Algebra 1, right? And we're going to do rise over run. So we want to start at one point and get to another. So in this first example, we would start here. We would rise 1, 2, 3 units, and we would run 1, 2. So the slope here is 3 over 2. Some of you are probably taking a sigh of relief because I personally think it's easier to find a slope from a graph, personally. Let's try this one. We can start at any point and try to get to the other one. So let's do 1, 2, 3, 4. Rise 4, run 1, 2, 3, 4, 5. Now we went to the left 5, so that is negative. So 4 over 5, negative. And it helps to just do a double check. This line is going down from left to right, so we know it's going to be negative. All right, now there's 2 sets of special lines. Parallel lines is the first one. Parallel lines have equal slopes. They are the same. So you can see 2 examples here. You might see the shorthand of this parallel. So we could say like line N is parallel to line T. So you might see this symbol here means parallel. The other thing you're going to see, if 2 lines are parallel, you might see little arrows on them. So that's an indication that they're telling you those lines are parallel. You might also see little triangles. It's another way to write that. All right, so if we look at this picture, these are just 2 examples. The 2 lines across from each other, these are parallel because they have the same slopes. Slopes are exactly the same. Same thing with these 2. Slope is 3, they're the exact same, so we know the lines are parallel. Perpendicular lines are the second type of slope. These are special because they have opposite reciprocal slopes. Opposite reciprocal. So before we look at an example, I want to show you the symbol for perpendicular is that. So you might see something that says like line N is perpendicular to line L. And there's the only other special thing you might see is this right triangle symbol. And similar to the parallel lines, all right, sorry about that. Similar to the parallel lines, we are going to talk about the slopes. So perpendicular lines have opposite reciprocal slopes. So here's an example. Let's say the slope of a line is 1/2. Then the perpendicular slope of another line would be the opposite. So this is positive, so we'll have negative. And then the reciprocal is you flip the fraction. So this would be 2 over 1. I have some people remember this by thinking of refliprical because you flip the fraction. Here's another example. What if we had a slope of a line is -2? A perpendicular slope would be, you make it opposite, so our perpendicular slope will be positive, and then we flip it. It'll be 1/2. Because remember, this is 2 over 1, so if we flip it, it's 1/2. All right, let's talk about the midpoint. The midpoint is the very center of a line segment. Here you can see it's marked with that purple dot and it breaks the line into 2 equal parts. So to find the midpoint, here's our formula. All you're doing is you're taking the average basically. You're adding the 2 x values together and dividing by 2, and you're taking the two y values together and dividing by 2. We're not going to do much with this right now. I just wanted to kind of introduce it to you, show you what it is, show you that it exists, and then to find it, we're going to use this formula. So here's our first example. You're given these coordinates of a triangle. Verify these vertices form a right triangle. Then draw the mid-segment of the triangle parallel to the hypotenuse. Okay, so let's get a grid in here. There we go. So we're going to plot our points. A is -2, -1. And B is 1, 3. And C is 5, 0. So we're going to connect these dots. I'm going to do it with a nice straight edge because you guys know just how good I can draw lines. Not very, right? There we go. All right. Verify these vertices form a right triangle. So if you were to look at this, you'd be like, oh, these lines look perpendicular. I mean, these lines look like the right triangle, but we need to confirm it. So remember, perpendicular lines form a right triangle. So if we can show that these lines are perpendicular, then we've shown they form a right angle. And we've shown that it's a right triangle. So let's find the slope of these lines to show they're perpendicular. So this segment here, AB, we would go up 1, 2, 3, 4 over 1, 2, 3. So the slope of AB is up 4 over 3. I started at A and I counted up 1, 2, 3, 4, and over 1, 2, 3. Perfect. Now the slope of BC, I'm going to start at C and get to B. 1, 2, 3, up 3, and over 1, 2, 3, 4. And we went to the left 4, so that's negative. And also BC is going down, so it's negative. Look at that. They are opposite. AB is positive, BC is negative, and they're reciprocals. It's the fraction flipped. So we just showed that, in fact, AB is perpendicular to BC, which shows they form a right triangle. Perfect. Next, draw the mid-segment of the triangle parallel to the hypotenuse. So here's the hypotenuse. And they want us to draw the mid-segment. So this is something that we're actually going to come to later, but I did want to throw it in here. The mid-segment of a segment which we saw on the last slide. Remember, it cuts a segment in half, and it's going to be parallel to the hypotenuse. So that would be, let me just show you over here in a triangle. The mid-segment of a triangle is like this. It cuts the two sides in half. So we can go ahead and do this. We would need to find the mid-segment between B and C. That would give us the middle point here. And the mid-segment between B and A. That would give us the middle point here. And we'd be able to draw that line parallel to AC. So let's do it. Let me erase. I keep saying, oh, we're going to do that later. Let's just do it now. So the mid-segment formula, remember you add the x's, divide by 2, and then you add the y's and divide by 2, and that gives you your new coordinate point. So we're going to add B and C to get the mid-segment of that right in the middle. I'm going to use these values up here. B and C. So 1 plus 5 over 2 and 3 plus 0 over 2. So our new coordinate point, the middle point of BC, is going to be 3, 3/2. So we're going to go over 3, 1, 2, 3, and up 1.5. 1.5. So it is right about where I put it. That's cool. Awesome. And then we're going to do the mid-segment between A and B. So -2 plus 1 over 2 and negative 1 plus 3 over 2. All right, we got negative 1/2, comma 1/2. So start at 0, we went over a half and up a half. So yeah, it is right about where I put it. Awesome. And then you just connect those dots, and there is that mid segment of the triangle. And it is parallel to the hypotenuse. See how they're going in the same direction? They have the same slope. If we found the slopes, then they would be the same. That was fun. Here's our practice. Which ratio, remember a ratio is just a fraction, represents the slope of a line parallel to line J? So they give you a line, and they want a slope parallel to it. So step 1 is going to be to find the slope of the given line. So line J, the slope we can do rise over run. 1, 2, 3, up 3, over 1, 2, 3, 4, 5, 6, 7. So the slope of the given line is 3 over 7. So now a parallel line to that, remember parallel lines have the same slope. So you just find the one that's the same. There it is, 3 over 7. I think this is our last practice. Which graph represents a line perpendicular to line K? Here's line K. We're going to do the same steps. If we want to know a line perpendicular to this, well, we first need to find this slope. So we're going to start here, and we're going to rise 1, 2, 3, 4, 5, 6. I always just go from one point to the other. We could probably have gone shorter. 1, 2, 3, 4. Yep. So this slope is 6 over 4, which is 3 over 2, right? So we could have just gone 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. It works both ways. But the answer, we want it to be perpendicular. So a perpendicular slope is going to be opposite, so negative, and reciprocal. We're going to flip. So we're looking for which line has the slope negative 2/3. So start at one point, and we want the one that matches down 2 over 3. Now 2 over 3. Oh, it's not that one. That one was not on the grid mark. Down 2. These are so close. Over 3. Nope, that one's not on the grid mark either. Down 2 over 3. Whoops. 1, 2. Nope. So it should be D. Let's check it. Down 2 over 3. Boom, right there on the grid. Down 2 over 3. Yay. It is D. All right, you guys, thanks so much for watching and for following along in your notes. You can always rewind this video. And again, thanks for your patience so much with the email outage. I know that they are working as fast as they can. And some people are back up. Like I know I got my email late last night. So I appreciate your patience on that. And I'll see you guys in class Thursday. Thanks.